So I think most of you have an understanding on how to do what we're going to do here in a little bit. And this is just the nuts and bolts of dividing with fractions. Okay? The process is very similar to multiplying with fractions. There's just a couple of things that we're going to need to do first. But again, this is the very shallow part of what we're going to be doing with division. Later on, probably tomorrow or so, we're going to look at exactly what does this look like when we're dividing with fractions. So the first thing that we're going to do with a problem like number one, okay, is we need to set this up and do this on your whiteboards. I need to see everybody with their whiteboards out and write down 6 divided by 1/3. Okay. We need to set this up just like we had to set up our problem when we were multiplying. We need to make we want nothing but numerators and denominators. Okay, so any whole number we need to change to an improper fraction. Any mixed number we find we need to change to an improper fraction. So I'm going to throw a 1 underneath that 6, making it 6/1. All right, divided by 1/3. So that's a good starting point. Now, what were you guys taught, maybe back in 5th grade, about how to solve a problem like this? What, Dallas? Okay, yeah, you might have heard of KFC, which always makes me hungry because I just love fried chicken. You know, I would eat it for breakfast, I would eat it for lunch, I would eat it for dinner, and I probably wouldn't live very long. But you know what? I'd die happy because I do like fried chicken. All right. Anyway, getting back to that. The K stands for keep, and that's what we do with this very first fraction. We keep it, we don't change it, it stays as it is. The flip, the F stands for flip, which stands for the reciprocal. We want the reciprocal, say that word, reciprocal of the second fraction. So that's 1/3. The reciprocal of that would be 3, 3/1. And then the C stands for change, and that's where all of a sudden our division becomes a multiplication sign. Okay? So now all of a sudden we're looking at problems that were identical to what we did yesterday because our division problem changed into a what? Multiplication problem. That's not too different from when we were working with integers. Remember when we were working with subtraction of integers? And what did we do with our subtraction problems? We turned them into addition problems, you know? So we can work with numbers, we can play around with numbers, and that would get us our correct answer. So now we just multiply across. 6 times 3 is 18, and 1 times 1 is 1, and 18/1 equals good old 18. All right, so we're good to go with that. Now let's see. Let's see when we have two fractions. Let's do number 2. We have 3/5 divided by 3/4. Okay? 3/5 divided by 3/4. And let's just see. Don't wait for me. Go ahead and see what you can do on this with this yourself. Really solving these things is pretty basic. I mean, as long as you're careful with your multiplication, as long as you're careful with your simplifying at the end, which some of you had some problems with multiplication. If you're careful with that stuff, then you'll do okay with what we're going to do today. I'll tell you though, guys, this gets a lot deeper and a lot more difficult when we're really talking about understanding what's going on. So hopefully by the next week or so, you guys will have it down. Okay, so I see 4/5 mostly, but not exclusively. Let's see what's going on. We keep, right? 3/5 change. It does not change. We flip. Getting the reciprocal of 3/4 would be 4/3, and then I change this division sign to a multiplication sign. Now, some of you that are really good with cross multiplication, you might look at this and say, okay, I could, you know, 3 can go into 3 once, and it can go into this 3 once, and then I end up with 4/5 that way. Others of you, if you had 3/5 times 4/3, could just multiply straight across, and I end up with 12/15. Now, if you had 12/15, that by itself isn't okay. We're going to need to simplify that can do that with our upside down division that we look. What number could go into 12 and 15 evenly? What prime number? Three could. Three goes into 12 four times, into 15 five times, and that's simplified as far as we're going to get. So that's how we get our 4/5. Okay. All right. We'll do lots of practice with that today. Okay, before we get started on our lesson, I want you guys just to explore with our fraction strips. We've got everything from halves to thirds to eighths to fourths to fifths to tenths to sixths, twelfths, and all, one whole. And I know, there's no sevenths, there's no elevenths, but that's okay. Yeah, there's no ninths. We're fine. We can deal with what we have. And so here's what I'm saying. I want you to explore, gentlemen. I want you to explore with these things. Okay, take a look at some, and maybe just compare. You know what we do with fraction strips is we, for example, let's take a look at eighths and fourths. Okay, if I put these side by side, what are some things that you notice? Okay, I'm noticing that. What were some things that you notice? What do you notice? Yeah, that we have 2/8 in 1/4. Okay, in 3/4. How many eighths do we have? How many eighths are inside of 3/4? How many? Nope. Nope. No. How many eighths are inside 3/4? This is 3/4 right here. One, two, three. How many eighths is that? What? One, two, three, four, five, six. So 6/8 into that in 3/4. Okay. What I want you guys to do now is just spend some time exploring with these. I'm only going to give you about 3-4 minutes or so. Look at how these work together. Not only guys, not only like what things work evenly together. You could look at like six and tenths, and see what kind of interesting findings you get with that. So go ahead and play around with these, and then I'll bring you guys all back together, and we'll start our lesson. Put it right over there. Okay, what did you discover? Go ahead and tell us.
That 2/6 is 1/3.
Okay, so that inside of 1/3, we have two 1/6 segments. Okay? Now, to translate that into a division problem, watch, because this is important that we understand. To translate this into a division problem, if we had 1/3, okay, and we divided that by 1/6, what would I get? Now we could do the standard algorithm and take a look at that. We could just use our keep, our flip and change, and we end up with 6/3. How many times will 3 go into 6? Twice. Okay? So with the fraction strips, we're actually able to see why the algorithm works. And that's important to do because we can't just know this. If we just know this, then we have a very limited understanding of division of fractions. Okay? All right. Anybody have something else? Those are yours. Okay. Allie, come on up. Allie, up a little higher. Like that. Okay, Allie, talk to us.
I figured out that 1, 2, 12 can go into 1/6.
That in 1/6 we have two 12, 12 1/12 pieces. Okay, good. So if we were to do now, let's keep this and let's look more than just 1/6. What if we did 5/6? 5/6 would be all the way over here, wouldn't it? Right where my pen is at. 1, 2, 3, 4, 5, 6. Right? How many twelfths would that be? Well, you know what? Let's figure it out. Just doing the regular. Let's say that we had 5/6, right? Divided by 1/12. Okay, so how did we do this yesterday? How did we solve this? So we kept this we flip this and we change this. Now we can cross simplify right here. 6 will go into itself once, and 6 goes into 12 twice.
2.
Okay? And now we multiply across. I get 5 times 2 is 10, and 1 times 1 is 1, so 10, right? And we can prove that by looking at this. In 5, 6, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay? So it serves as a very, very good visual for what this actually means. Okay? And from this, we can develop all kinds of interesting word problems. Underneath the standard that you wrote down, remember our standard that we're looking at is interpret and compute quotients of fractions and solve word problems involving division of fractions by fractions. Okay, a lot of words there. Hopefully it's starting to make a little bit more sense to you, but write this problem down. 3/4 divided by 1/8. And next to it, I want you to go ahead and apply just that standard algorithm and solve this problem. I mean, just the regular old keep, flip, find the reciprocal, change, and give me an answer. And then next, I want you to find your 4th strip, okay? And then your 8th strip, okay? You're going to do that next, and let's just put those right up next to each other. We're dealing with fourths, but we're actually dealing with 3/4. Okay? You guys have that down? Good. All right. Now, by the way, what did you get as your answer? Right. Okay. I got that as well. Okay. If we applied the regular old KFC on this thing, you should have gotten 6. Now, where would 3/4 be? This is 1/4. This would be 2/4. This would be 3/4, right? So it's right here. Sometimes it's good to leave like a little place marker there. Now, how many eighths is that? 1, 2, 3, 4, 5, 6. There it is. Okay. Now, you might see this. Well, the reason why we do this is because sometimes you will be asked to explain why. Why does 3/4 divided by 1/8 give you 6? And you're going to need to be able to illustrate that. So you're being called up a lot higher than it used to be, where you just had to, solve the problem. Now you have to actually illustrate and show and explain why it does that. So let's do that real fast. Down below, I want you to draw a little model of what's going on right here. Okay? Just draw a little model of your fourths and your eighths. And show how we ended up with 6 as our answer, because that's kind of important. As you're doing that, I want to remind you that part of what we need to be doing today is thinking about how does this work with word problems? What would we see with a word problem? I know I'm dealing with 3/4 of something. Is that a full amount, or is that just a fraction? It's just a fraction, right? So it'd be like saying, I got it. Let's say you have a pet turtle. Anybody have a pet turtle here? No? I used to, and it escaped. They are escape artists. You wouldn't think they could escape really fast, but they're a lot faster than you think. And I had mine escape, and I don't know where it's at anymore. But anyway, let's say that Mr. Penning has 3/4 of a cup of turtle food left. Okay? Are you picturing that? 3/4 of a cup of turtle food. Each day, the turtle eats 1/8 of a cup. Are you picturing that? So 1/8 of a cup. How many days can Mr. Penning feed his turtle with the food that he has? And my answer would be what? 6 days. Okay? So what we can do is we can take a given equation, a given problem, and apply a real world situation to it. And vice versa. We could take a real world situation and turn it into an actual equation. Okay? And that's what we're going to be practicing a lot today. So let's get all this down, and then after that, we'll get into this a little bit more. Okay? Okay, so this worksheet that I made up has 4 columns. Okay, there's 3 of which you're going to have to come up with something here. Okay, we've got the problem. Okay, this is just a regular, basic, just division problem. We've got an application. An application is taking the problem, and applying it in a real life situation, applying it in a real world scenario. Then we have the solution. The solution is going to be done with just the regular algorithm. So just solve the problem. And then the illustration is where you're going to draw out what you found using your fraction strips. Okay? So let's look at the application first. Read it along with me. I mean, I'll read, you just follow along. It says there's 2/5 of a yard of fabric left. Okay? So you picturing that? Picture like a felt, picture like a soft fabric, because these are going to be for Christmas stockings. Little ones, like little miniature ones. All right? There are 2/5 of a yard of fabric left. Emily wants to make stockings for Christmas, for Christmas for her friends. Each stocking needs 1/10 of a yard. How many stockings can she make? Okay? So we take the amount that we have left, which isn't much. It's only 2/5. Okay? What I need is, for each stocking, is 1/10 of this. Okay? So we want to figure out how many 1/10 sections can we get out of 2/5. Okay? Got it? So solve that right over here in this box. Go ahead and solve that. Just the same way you know how to do. So we're going to go 2/5 times, well, actually divided by 1/10, which is going to equal 2/5 times 10. And what do we get? 4 what? Nope. Stockings. 4 stockings. So she can make 4 stockings with the fabric that she has left over. Okay? Now, let's actually illustrate this. What two number fraction strips are we going to need? 5ths and then 10ths, right? Okay? So we're talking 2/5, and we want to know how many 1/10 pieces fit into 2/5. And what's our answer? 4. 1, 2, 3, 4. So illustrate this. Illustrate this right over here where it says illustration. You're going to draw out what's going on right here. Okay? Right over here. Draw that out. And what? No. You're gonna draw out what you did with your fraction strips. Okay? And I don't think you need to draw the entire fraction strip. I think we just need to draw the part that matters, and that's the 2/5 and 4 1/10 sections. And that's it.